Okay, welcome to 6.8 here. Okay, there's a lot going on in these rational graphs here. So first of all, if we take a look at this is a rational function right here. So the first thing that kind of pops out to me is right here. What is that point? You see that's an open circle. That means the graph does not exist right there. So you can say that this graph has a hole at the point 2 comma negative 1, right? And now what else can we see here? We can find our horizontal asymptote at y equals 1, and then our vertical asymptote at x equals negative 3. So those are our two asymptotes visually, right? So we've got a vertical asymptote at x equals negative 3. And then our horizontal asymptote at y equals positive 1. And then if we take a look at some other information here, I can see that right there is our y-intercept, right? So our y-intercept is at 0 comma negative 2. And then our x-intercept hits over here at 6. So we can say our x-intercept is right here at 6 comma 0. Okay, so there's a lot going on with these rational functions. And you can see here we've got holes, we've got vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts. So it's all information that we need. Okay, so that's what it looks like visually here. Okay, so what we're going to do here is how do we find all of these if we have a function? So this is where our factoring is going to come into play. So if I factor this top here, I'm going to get x minus 2, x plus 2, all divided by x plus 2. So there we go. Right away, the first thing that we notice is that x plus 2 and x plus 2, they disappear. It's like a ghost. So what does that look like on a graph? Well, that is going to be a hole. So we're going to have a hole at negative 2 comma some number, right? Where does this equal 0? So if I do x plus 2 equals 0 and I get x equals negative 2, I know that there's a hole there. Okay, so if it disappears and I plug in f of negative 2, now the only part left is x plus 2, so, or sorry, x minus 2, so negative 2 minus 2, that would be at negative 4. So there's a hole at the point negative 2, negative 4. That's the part that disappears and goes away, okay? So now we know that our function here is this. Our function is f of x is really just the function x plus 2. All right, I'm sorry, x minus 2, all right? X minus 2, because everything disappears. Okay, so is there a vertical asymptote in this function, right? And the answer is no, because it's just a linear function now, right? Is there a horizontal asymptote in this function? And the answer is no, right? And what is the x-intercept? Well, the x-intercept is, well, what if y equals 0, right? Okay, so if y equals 0, I would say 0 equals x minus 2, right? And then just solve for x. So I add 2, so I would get 2 is equal to x, right? And now if I want the y-intercept, right, I'm just going to say, well, what happens if I substitute in 0 for x? And then you would get f of 0 is negative 2. So the y-intercept will be the point 0 comma negative 2. Okay, so what's nice about these functions is sometimes everything goes away, right? Once I start factoring in the beginning, you find out there's going to be a hole right here. And then if I factor everything, it just turns into a linear function, right? So there's no horizontal asymptote, no vertical asymptote. There is an x and a y-intercept, okay? All right, so next function, let's kind of take a look at this guy. What is going to be happening here, all right? So if I look at f of x, the first thing that I'm going to do is what can I factor? Can I factor anything here? Well, let's just factor this into x minus 3. And then x plus 2, right? And now the denominator, right, we have an AC method, right? So 2 times 10 is 20, right? So I've got 20, right? And then what are my factors of 20 that add to 9? Well, 5 times 4 is 20, and 5 plus 4 is 9, right? So don't forget to incorporate in this 2. So I've got x plus 5 divided by 2 and x plus 4 divided by 2. So I know what's going to work. Well, 2x plus 5 is 1. And then the other function is just going to be x plus 2. Now, what do you know? Okay, there it is. There is our ghost. There is our hole, right? So where does that hole exist? Our hole exists at -2. So I've got -2 comma something, right? Now remember, our functions change once we simplify it. So the function that we're looking at really here is I'm going to plug in -2 into the simplified function. So I've got -2 minus 3 over 2 times -2 plus 5. All right, so this hole is going to be at -5 divided by 2 times -2 is -4. -4 plus 5 is 1 at -5. Right there is going to be the hole. Okay. Now remember, if we have a vertical asymptote, is where is the denominator equal to 0? Okay, and remember, we're looking at this function now, right? It's just this function. Okay, so where is the denominator equal to 0? Okay, the x plus 2 is gone, so I'm going to say, well, 2x plus 5 equals 0. So I'll just solve and find out where it is undefined. 2x equals -5, divide by 2, divide by 2. There's going to be a vertical asymptote at x equals -5 over 2. Okay, -5 over 2. Okay, the next thing I want to look at, and is again, remember, I'll rewrite the function down here after it's simplified just so we can kind of look at it. I've got x minus 3 over 2x plus 5. And we understand that the power up here is 1, the power up here is 1, so the leading coefficients, right, 1 over 2 gives us our horizontal asymptote. So y equals 1/2 will be our horizontal asymptote. Okay, and now the last two things we need to do is understand that what are the x-intercepts and then what are the y-intercepts here. Okay, so what's interesting here is the x-intercepts is where y is equal to 0. So this is a little funky, but if I'm going to say 0 equals x minus 3 over 2x plus 5, the only thing that I need to concern myself with is the top, right? So where is the top equal to 0 in order for this statement to be true, right? So if I say x minus 3 equals 0, x equals 3. Right, so I know that the x-intercept now is going to be at 3, 0. And then the last one is the y-intercept, right? And remember, the y-intercept is just if I'm plugging in 0 for x, right? So I would get 0 minus 3 on the top, and then 2 times 0 plus 5 on the bottom, which would simplify into -3 on the top, and then 5 on the bottom. So I'll get 0, -3/5 as our y-intercept, okay? And as you can see, right, there's a lot going on here, but the math is really simple, right? There's just a lot kind of going on here, okay? All right? So if we wanted to take a look at graphing one of these, let's graph the top one. Right one here, x squared minus x minus 6. Okay, so we're going to go ahead and take a look at the graph of that, right? Let's clear this out of here. We've got alpha y equals, just throw it right in the top. So I would get x squared minus x minus 6 on the bottom, right? And the denominator is 2x squared plus 9x. Was it plus 10? I think it was plus 10. Let me just double check. Plus 10 it is. Okay, so if I go ahead and take a look at the graph of this one, let's check it out. There is our horizontal asymptote. Our vertical asymptote. Okay. And if I wanted to find out where the x-intercept is, there it is, right there, right? 3, 0. And then if I wanted to find out the y-intercept, right? There it is, negative 0.6, which was our fraction that we got. And then the one place which was weird was the hole, right? So where is the hole? Negative 2, negative 5. Let's see if that exists on the graph. So I go to negative 2 here, negative 2, and then negative 5. Let's see if it zooms in here. I don't know if you'll see it on my calculator, but the point, this point right here, negative 2, negative 5, that hole won't exist. Yes, my calculator won't even pick it up. It'll get close to it, but it won't even pick it up. I'm wondering even if we zoom in, will we see it, right? Negative 2, yeah, it'll just jump right over it, okay? But the hole does exist right there, okay? All right, y'all, I know that's a lot of information, but the math is easy and you can do it, all right? Good luck.